Okay, so let us talk about sequence and acknowledgement numbers a little bit in detail, and let us try to understand it with the help of an example also. So as we discussed, the TCP views data as unstructured but ordered stream of bytes. So it means machine A and machine B will be establishing a connection first, and then machine A will be sending a sequence of bytes from a sequence of bytes will be transferred from machine A to machine B. So in this case, the sequence numbers are over bytes, not segments. So a segment number is basically the initial byte number in the segment, right? And yes, the initial sequence numbers are selected or chosen randomly. TCP is a full duplex communication, means we number the data irrespective, independent of the direction. And similarly, the acknowledgement numbers are the last byte number plus one, means the next byte number that is expected from the sender. And this is very important. In TCP, the acknowledgements are cumulative. We'll discuss this in a minute in more detail. So I leave it with a question mark. So, so let's first try to understand the sequence numbers and acknowledgement number with the help of an example. So for example, machine A has to transmit a segment to machine B, and it has to transfer 1,000 bytes, and the starting byte number is 42. So what will be the sequence number? Yes, you're right. The starting byte number, which is 42, and obviously, say this is an ongoing communication. Earlier, B has transmitted a segment to the last byte number was in the data was 878. So this time, the acknowledgement by machine A is 79. This means host A has received byte numbers up till 78 and is ready to receive by a segment starting with byte number 79. So look at machine B. So we assume that machine, to simplify the scenario, we assume that machine B has nothing to transmit now, but it has to acknowledge the received segment. Since TCP is connection oriented, means there are acknowledgements in TCP. So what will be the sequence number of the segment transmitted by machine B? Yes, you're right, 79, because host A is expecting segment number, a segment starting with byte number 79, but there is no data to be transmitted, remember. So what will be the acknowledgement? This is important, and I want you to pay attention. What will be the acknowledgement number in the segment transmitted by host B? Yes, 1043, but how? Remember, the starting byte number was 42, and how many number of bytes are being transferred? Sent 1,000. So this means this will go up to 1042. So what will be the acknowledgement number? The last byte plus 1, right? So the last byte number that machine B will receive is 1042. So this means the acknowledgement will be 1043. Means B has received data up till byte number 1042 and is ready to receive a segment starting with byte number 1043. So now look at this, the next segment that is being transferred by or generated by host A. What is the sequence number? The acknowledgement number, 1043. The TCP segment starting with byte number 1043, and it is again asking for data starting with byte number 79. And we send the data, and how many number of bytes we are sending? 500 this time. So this means what will be the last byte number? The starting byte number plus the number of bytes that we are sending, right? So obviously, if we are sending 500, so this means the last byte number will be, yes, right, 1042. 543. So what will be the acknowledgement number by machine B? The last byte number plus 1. Yes, you're right. Right? So again, the acknowledgement number is 1544. So I hope students, aapko ye pata chal gaya hoga that how the sequence numbers and acknowledgement numbers are decided in TCP, are maintained, are selected in TCP segments. By the way, we'll be talking about the sequence number more in TCP connection establishment in the next class, because it's tricky to avoid different types of attacks. So we'll have a detailed discussion